Okay, good morning. So the title today is IBM Software Sub-Capacity Licensing definition, and we have scenario examples to reinforce the understanding. There is a disclaimer whereby we compiled the webinar at Goodwill as a company, and we used IBM documentation. IBM has not endorsed this presentation, neither did we request an endorsement from IBM. So Kisalu is not responsible for errors, omissions, or misinterpretation. Please contact your local IBM representative if there is a need for clarity. The content today, we will have a short introduction. For those that were there yesterday, it's almost the same. And we will have a definition of software sub-capacity licensing. Then we'll go through examples just to show how the software sub-capacity licensing applies. And then we will conclude. So it should be very short. This one, most of you have seen. So many organizations are using virtualization to reduce their costs for running IT. And the IBM software that runs on such environments, in virtualized environments, can attract a lot of savings, but may also become a burden if not properly used. We've seen that yesterday. And there is an agreement that governs the relationship between IBM customers and the IBM. Within that agreement, it is stated that any IBM software which is run on virtualized environment will need to be monitored through ILMT. It is compulsory. And also, the ILMT is the only tool that is free and recommended by IBM. Either you can also use IBM Big Fix Inventory, but it is not free. And ILMT is available to all IBM Passport Advantage customers. It is free, but you need to order so that you can benefit your support, maintenance, renewal, and telephonic support. Defining the software sub-capacity licensing, what do we understand by that? We go through the phases that technology evolved over time. So defining the software sub-capacity licensing will be better understood that way for those that are not well clued into those changes. Before the advent of multi-core processors, IBM customers were licensed based on the relationship between the server, which is the processor, and the product. So we only had that relationship. If you can see on the first bullet, each single core was awarded a certain amount of money, and that's what you paid for the software. Then came around 2005 and 2006 the advances on technology which brought multi-core processors in the market. Then IBM officially announced the changes whereby there will be a new way of licensing product. They installed a new metric which was called the processor value unit, or PVU, and then discarded the per processor licensing for many of the products in 2006. You can see now there is in the market in 2005 and 2006, whereby from one chip they could create dual cores, dual processors into one, or even more. Now You can have quad cores in one chip or even more. So those advances then imposed changes on how IBM were to be licensing the product. So the PVU licensing model is based on processor cores. It's not based on just one server or the chip that you have. Then the costs for multi-cores were now oriented based on your computing powers that the software was using, based on the performance of the cores that you were running the software on. Because if you take a one processor machine compared to a dual processor machine, the power is much higher on the dual processor, although it's one machine, one processor, but it's dual core on each of them, on the second one. So the power is much higher than on the single core. So IBM then decided to charge more on a machine that will present higher performances compared to the one that will have lower performances. In that sense, the physical environment, that if we need to define how to view it, we should go back to understanding the physical environment. Here we have an example of a server which has the server has two sockets, and each socket has 4 cores. So for the total environment, the total server, we have 8 cores. Initially, before 2005, 2006, if we were to license the server, we wouldn't count the cores. We will just have 2 sockets, which would represent basically 2 processors, because we didn't have multi cores that could go into one socket. So that is the difference. So now, because technology allowed that people could stitch multi-cores on one socket, so it made it now a bit difficult for IBM to license the products. Then they had to change the model. If we need now to understand the sub-capacity licensing, we will go from that physical environment to the virtual environment. Here we have the same physical environment which we showed in the previous slide, but now we want to see that the technology allows for people to run on this physical machine. If you take a VMware or you take the Microsoft Hyper-V, you can now redistribute, create new machines on top of that physical server. You can create multiple machines and allocate, using the software, the VMware software or the Hyper-V or any other software, which are called your virtualization technologies, so that you can create different machines where you want to now run the software. So from this physical server, we can create three VMs, for example, and instead of keeping this 8 cores, we can even use the same software, the VM software, to allocate different type of cores for those virtual machines that we created, to the point that here we have 2 sockets with 8 cores, but here when we virtualize, when we create on that machine virtual machines, we can even go beyond the number of total cores that we have. So we can create VM1 and allocate 4 cores, VM2 3 cores, and VM3 2 cores. If you count, we have a total of 9 cores, which is even higher than the 8 cores, the physical cores on the machine. So all those are the difficulties that came with virtualization and and how now people could play around uh, with creating new environments, and that brought issues also in terms of licensing. How do you now start licensing software where people will run on a smaller virtual machine? Here we have 8 cores, but they can choose to run that software on a 2 cores or a 3 cores, or even run the software on the 3 machines, which now represent 9 cores instead of 8. So all those were the issues that were to be resolved in terms of licensing. Hence, they came up with the PVU scheme so that they can allow people to benefit from virtualization. At the same time, they will be able to track how people are using the licenses. So let's say you have this big machine which has 8 cores, and you have a software that costs you $100 per CP per core, because they will be charging per core. So for this one, you will be paying $800 because it's $100 per machine. But if you say, no, I don't want to run my software, my IBM software on the full machine, I want to create VMs, and I will only run it on a very smaller machine where I'll put 2 cores. Instead of you paying $800, you will then be charged $200. So you save, but the problem is that IBM has no ways, no means of knowing that you are running your software on a 2-core machine continuously. Because let's say now you feel the need to increase the performance of the machine. Maybe at the end of the month you have too many processes running. You say, okay, the virtualization technology will allow you, maybe in your environment, to add another 2 cores, take it from this VM and push it down there. Then this machine will now have higher performance and give you a higher output, which normally you should be paying higher rates for it, but because IBM has no means of tracking that, you can swap your cores in between your months or days within the year, and IBM will have no ways of picking that you've been playing around with the cores. Hence, the ILMT becomes compulsory so that IBM will know how you were playing with your cores in between your VMs that you created. Yes, you can save money, but if they catch you that you've been playing with the cores and you did not inform them, then they will charge you this $800 as a full capacity instead of your 2 cores. Plus, they may give you a fine of 2 years backdated. So it will be 800 times 2, which is 1,600, plus your 800 for that year, that will be like 2,400. And here I'm just giving an example so that we understand. But if it was 1 million here, it will be around $3 million. So it can become very nasty and very bad. It is not a nice situation to be in. Okay, so we can go to the next slide. As part of defining software subcapacity, so it is that the subcapacity licensing is a scheme that will base the charges on the partition where the licensed software is running rather than on the total. That's what I explained just on the previous slide. And you are licensed the PVU and in the PVU scheme less than the full processor capacity of the server, whereby you choose to maybe run the software on a smaller VM on a smaller machine, provided that virtualization is recognized by IBM because it is eligible. So IBM issues regularly which virtualization technologies are allowed into the subcapacity license. So with that ability to increase and decrease the power of the machine you're running or the VM, you will only choose to pay what you really want to use for your environment. So the consequence is that you are licensed at full capacity unless you take the steps which are relevant so that you can be recognized for that particular software as licensed at subcapacity. There are a few exceptions like we've seen yesterday in the previous presentations. Then IBM will consider that you are at full capacity unless you have ILMT and it is implemented as we've seen yesterday. What does it mean in that situation? It means that if you do not have ILMT implemented and you do have your software running on a virtualized environment, it is that if you don't have ILMT implementation, you can just understand that your customer does not have subcapacity right. If you do not have subcapacity right, it means that you are just going to pay full capacity IBM licensing fees. So that's what it means. And under that full capacity, you must license all your physical processes that are active in the server. As a small example, if we have a P-series machine which has 62 activated cores, and you dedicate and cap one small VM or LPAR, they call it there, of a unit 0.2 running your IBM software, like let's say DB2. If it is 0.2, they'll round it up to 1 core for the micro-partitioned LPAR. Then you will be licensed at 1 core. But if you do not have ILMT, then you will pay for the 62 cores on the full machine. And on a P770, for example, this difference can be around $2.8 million times 11, that can become 22 million rand. It is not a nice place to be. So we have a few scenarios that we picked from the website. They all on the website. All the information we're sharing is IBM information on the website. The subcapacity examples that we have, there are many of them, many scenarios that we can have for the thousands of products that IBM has. And based on the concepts that we have explained above, we have a few examples that we will discuss based on the VM machines with the different cores that we selected. The examples below, we will see MQ software and IBM's WebSphere software, which are used to illustrate how licensing can be determined. The first scenario is full capacity. So we have for example, a IBM MQ software install. By the way, this will apply mostly also the concept that we're sharing now will apply also the thinking will apply to most scenarios that you will have for your customers. So if MQ is installed on a server with two Intel Xeon processors, each of them with 8 cores. So we see this is the server. It has two processors which 8 cores each. So we have 16 in total. Then we have a full machine with running MQ, IBM WebSphere MQ. Our environment is not virtualized, it's full capacity. So sub-capacity licensing does not apply. Full capacity will apply, which will be the highest numbers of PVU on the server where the software is installed. There is something called PVU table. That is a subject on its own. The PVU table, it's the processor value unit table, which is a table that IBM issues regularly to show how they will rate a particular processor model in terms of the processor value unit. So they give a rating to each processor that's in the market and which already has been eligible as technology. So there is a table that IBM updates. It's on the Passport Advantage website as well, where they will say for this particular processor, each core we give it a 70 PVU value. So you will need, when you need to do this exercise, there is no way in terms of sub-capacity there's no way you will not use the PVU table. You have to use it unless you don't want to benefit the sub-capacity. If you want to benefit the sub-capacity, you have to look at the value of each of the processor that we want to use, what will be each PVU value for the processor. So from that table, we can see that this processor has a value of 70 for each of the cores that the software will be using. So because in this situation here, we're talking of full capacity, we will just take the full capacity, which will be, we will license the full machine, which has 16 cores, and we will pick up from the table. It says for each core, the value is the PVU value, the performance, let's say the performance that IBM gives it is 70. And we will then have to license 16 times 70 PVUs, which will be the total PVU counts for that machine. Then now we come to the costs, because then IBM will give you the cost of the software for each PVU. That one you get it from documentation that IBM sends to the customer, the price for each, or when you ask for quotation from your distributor. So they will give you the price for each PVU. Then you will take all of that, compute it, and get the value, the amount that you will need to pay for you to license MQ on this server, and the licensing will be on full capacity. I hope I'm not too fast. Okay, let's go to the next scenario. Now, the second scenario is that we have a case where we virtualize the machine. Here we have two virtual machines. As per the previous example, we have one big server which has 16 cores, But we then split and use the technology, the virtualization technology, and create two machines, and each of the machines we give it 8 cores. So it's the same machine, but we create two virtualized machines, and we give each machine 8 cores. And we install MQ on both machines. Remember, they are separate now. It's no more viewed as one machine. It's two machines using the technology. So we install MQ on both machines, which means that our MQ will have access to 8 cores each. And we also install WebSphere on the first machine. So now, when we need to compute, we will still need to obtain for each of the technologies, we will still need to obtain the value of the PVU, even if it is virtualized. So you will go to the PVU table and pick up the correct value for that virtualization machine. And here it's 70 per core. And we will then use that information to compute the need that will arise for the pricing of the software that we are installing on these two virtualized machines. As an indication on how it would have cost if it was not virtualized, we take the value of the full machine, the full capacity. This is on the table. So the full capacity would have cost us, remember it's 16 cores, so we will have the full 16 cores, and the PVU per core is 70, and the price is 50. So we will have for each, we are running MQ and WebSphere, and if it is full capacity, which means we do not have virtualization installed, each of the software will have access to 16 cores, which means that each of the software will have to pay the 16 core times the 70 PVU per core plus times the $50 that we're giving per PVU for the software. And we will multiply by 2 because we have two software there, MQ and WebSphere. So that will cost us $112,000 on a full capacity machine. Now, if we now go to our situation scenario 2, where we want to use the sub-capacity virtualized environment, MQ software, we will have access to this machine, with this virtual machine, which is 8 cores, and the second virtual machine, which is also 8 cores. So MQ will have access to 16 cores in total. And WebSphere, which is only running on one virtual machine, will have only access to 8 cores. So it means for MQ, we will also go pick up the PVU rate, which is 70, and the cost per PVU, which is 50, which is that now for MQ software, we will pay 16 cores total times $70 PVU per core, and times the $50 per PVU, which gives us a total of $56,000 for the MQ software. But for the WebSphere software, it only has access to 8 cores. So it will be 8 times the PVU per core, which is 70, which we'll pick up from the PVU table. And then the price per PVU, which is 50. Then we will pay 8 cores times the 70 PVU per core times 50. So for WebSphere, we will pay $28,000. So in total, if you want to compare your price, the sub-capacity pricing to the full capacity, we will save 28,000 because WebSphere only has access to one virtual machine, which is 8 core, compared to the previous situation. If we had full capacity, then we had to pay the full $120,000. Okay, so the third scenario is that we have a VM manager, we have our virtualization environment, but within the ILMT configuration, we do not have what is called VM manager. It is not defined. What is a VM manager? It is the fact that when you install, if you look at the scenario where I explained how we can go from a physical environment to the virtual environment, the virtualized environment, I mentioned that IBM will have no ways of finding out how you are using the software. Hence, we need ILMT installed. But within ILMT also, you need to give it the intelligence to understand that it is not, the software is not installed on the physical machine, but rather on the virtual machine. And you need to give it the intelligence to understand how are the virtual machines configured, how many are they, which one has how many cores. So for you to do that, you need to run what is called a VM manager within ILMT. So you need to define it. Let's say you have your ILMT and you have your virtualized environment and you did not define the VM manager. It means ILMT will have no way of understanding how your VMs, your virtual machines, are configured. Hence, ILMT will not have access to the information on how many cores, how many physical cores you have on the machine for each of your virtual machines deployed. So that is the issues that we have on the VM manager if it is not defined. What will be the consequences? The consequence is that if you do that, the virtual machine is not defined, so you have basically your full capacity. And if you did not define your VM machine, you will just basically pay your software at full capacity. There is a danger here. For example, we have the ability, as I shown before, you can create a VM and give it higher cores than the physical machine has. So if I've got a machine which has a physical core total of 16, I can create two virtual machines and give them higher than the 16 cores. So here I'll give them 12 and there I'll give 10 on my virtual machine. So if it's on full capacity, it means I will only pay 16 cores in total. But here, because I over committed my machine and created 22 cores on a total of 22 cores on the machine, if it is not defined, I will have, if it is defined, it means the VM manager will have accurate information of your environment. It will know that I've got 16 cores and I created 22 cores, which, because I've got 16 core total, the rule from the licensing is that you cannot license, you cannot pay more than the physical machine cores can allow you. If your machine allows you a total 16 cores full capacity and you have 22 cores in terms of virtualization technology, if the VM manager can demonstrate that, it means IBM will only charge you if in a sub-capacity scenario, the they will only charge you 16 cores. They cannot go beyond that. Hence, if on your full capacity for the MQ software, you will pay 56,000. On a sub-capacity where your VM manager is defined, where your ILMT can recognize the technology, the virtualization technology, and can extract details of your VM machines, then it will inform ILMT reports that you have 22 cores deployed, but your limit is only at 16. Hence, you will not pay the 22, but you will pay 16, and your cost will remain at 56,000 US dollars. If your VM manager is not defined, the tool will only show that you have 22 cores, sorry. Then the PVU table for a non-defined machine with VM with the virtualized technology may show that instead even of your PVU performance per core to be 70, it may show it is 120. There are rules, so you just need to go use that table. It will tell you which technology is it. If you say unknown, it gives it a different rating. So that's how we may reach even 120. So here you have a higher, the VM technology is not defined, and it gives it a higher rating for the PVU. So you will still have your 16, but the price there per PVU will increase because the performance rating is higher, and you will pay now 96,000 US dollars because your VM managed machine is not defined. We have another scenario which is very interesting. There are new technologies since 2013, 2014, which is called the Docker. So Docker is a technology which allows to have, for a better explaining, I will say, a virtualization of your software, of your application. With the previous situations here, we were virtualizing your hardware, where we split the hardware and we create different machines. With the Docker technology, they create what is called containers, and within those containers you can then deploy your application. You can run your application, and then you can use it efficiently in your environment. It is more and more used. So from ILMT not the 9.2.10, you can discover those applications that are running in containers, on Docker containers, and measure the metric utilization. It is not a sub-capacity eligible virtualization, but it can be used combined with the eligible virtualization technology so that you can monitor your applications, your software that you run. We have a few examples that we picked from the IBM website. There are conditions. So the Docker it is the technology, it is another technology that will be now deployed on the physical server. Then on top of that, you can then deploy your application, your virtualized applications. Not virtualized application. You can run multiple applications in containers that can run different applications. Now, the Docker engine, there is what is called a Docker engine must be deployed on the physical server, and then you can, with ILMT, measure your PVU and RVU utilization on the computer. As examples, we have inside a Docker container, example 1, we have 3 physical containers. We have a Docker engine and we have our host computer. So we have a 4 processor Intel machine, which each has 24 cores. So no, each has 6 cores. So we have 4 processors, 6 cores each, and we have 24 cores in total. Sorry about that. And we have MQ installed because they created a Docker environment. So they have containers where they want to run software. So if you look at the previous scenarios where we had VMware, where we could split physical machines. Here we're not splitting the machines. We have one host computer and they use a different technology called the Docker. And with the Docker engine running on the host machine, and they have containers. Each container can have different type of applications. So you can have DB2 here, you can have another container with a different type of, or you can have on your container 2, you can also have MQ, WebSphere, DB2, the way you want it. Now in this case, your MQ has access to all 24. So you have those 2 containers. They have access to the whole 4 processor and to the whole 24 cores, because that's how they're running. So if now you go into the preview table and the table says that you are assigning a value of 100 to each of the PVUs per core, it means our MQ, which is running on 2 containers, will have access to the full 2,400 PVUs. If we also installed another MQ here on a 3rd container, the value will stay the same because MQ as a whole will still have access to only 24 cores. Now, in the second situation, the second example, we have, if you remember, they said the Docker technology is not a virtualization technology. It is not recognized as a negligible virtualization technology as per IBM on ILMT. So the way it will apply is that there will be a combination with recognized virtualization technologies, then they can be used together with the Docker technology. So Docker can be deployed on a virtual machine. So if it is deployed on a virtual machine, so the counting will also be based on the highest number of PVU that are available to the virtual machine. So here we have the same host computer, and we have the host computer and we have 2 virtual machines. We coming back to the previous situation where we were going from physical machine to 2 splitted virtual machines. So for each machine now, they're running the Docker engine, and on top of the Docker engine, they're now running containers. So if we have to count how the software will have access to the virtual, to the cores, here there is a clear split. It's no more directly to the host machine, but your Docker technology now has access to the virtual machine. So for the containers that are running there, your MQ will have access not to 24 cores anymore. It will have access to 8 cores here. And there we can run 2 containers. Each of the container will only have access to 8 cores as well. So we will have the BigFix client, which will then pick up the BigFix in the first scenario. In the first scenario, our BigFix client is installed on the host computer. On this second scenario, we have the BigFix client, which picks up the information for ILMT, is installed on your virtual machines, not on the host computer. Okay, so from this second example, we can see that the two virtual machines are on the host computer, and each has 6 cores. So we have a total of 24 cores, but each virtual machine has only 8 cores, and each machine has 2 containers deployed. MQ was installed in 1 container on the first virtual machine and on 2 containers on the second virtual machine. So MQ that is installed has access to 8 cores, although in total it has access to 16 cores and not 24 like we've seen in the previous case. So here it has access to 8 cores. Here on the second virtual machine, it has access to 8 cores as well. Instead, we have 24 cores available on the host machine. In the previous situation, you would pay for all the 24 cores, but now you can also reduce your cost and pay only 16 cores in total. Then you will go to the PVU table to pick up the value for your PVU, and then your PVU utilization for the 2 machines, the 2 virtual machines, will be 1,600 PVUs, and then you will only charge for that instead of 2,400 PVUs. To conclude, sub-capacity licensing must be understood and applied correctly under the conditions that IBM recommends. We know now very well ILMT is free and can save millions like we've seen. And IBM clients must understand the sub-capacity rules as they apply for compliance to benefit reduced software license fees. And there are many scenarios that exist for the thousands of IBM software products, and there is over 140 schemes for licensing product as aligned to their different methods, different types and even different versions for each product. So it's advisable to obtain the required knowledge and avoid customer unnecessary conflicts, misunderstanding, and non-compliance fees. For more information, you can contact us at sales@kisalu.com. If you have any questions, we can exchange now. And thank you for your time. Thank you for coming to the presentation.
Thanks, Mark. This is quite interesting, actually.
Thanks, Shepard. We appreciate it. Byte team, do you have questions? I see your microphone opening up. Okay, if you don't understand some of the concepts, please send us an email. I understand for some of you, a lot of things might be new, even terminologies. Just send us an email. We will try and assist you in a way that will be acceptable. Please come closer to the microphone. I cannot hear somebody talking there, but I can't hear. Or you can write on the chat. Hello? Going one, going two, going three. Okay. We really thank you for your time, and we appreciate that you are. Is there somebody asking a question? I can't. Okay. Thank you so much. We can then close the call. We look forward to your feedback, and we will meet again next time. Thank you. Enjoy the day. Bye.
All right.